Hi everyone, a very good evening to all. Now we are going to study about the question number 86, that is radiation, heat radiation. So heat radiation nothing but heat travels from one place to other place without requiring medium or without affecting the medium through which it is traveling. That kind of transfer of heat we call it as radiation. And here the very first thing what you have to understand is what is emissivity. So emissivity is emissive power of a surface by emissive power of black body. W is called emissive power. So now what is emissive power? So emissive power means heat radiation emitted per unit area per unit time, or radiation power per unit area. P equal to Q by T is called radiation power. So this is the definition you need to understand first. So that in case of black body or perfectly black body, epsilon will become WB by WB, that is 1. For all other, the epsilon, E or epsilon emissivity will become less than 1, because only perfect black body can emit all the radiation. Remaining surfaces can emit only partially, part of its radiation. But one thing you have to remember, that when you consider any body at any temperature, it always emits radiation. So emission of radiation, absorption of radiation happens simultaneously. But if emission is more, there is a decrease in temperature. If absorption is more, there is a increase in temperature. But our loss of heat energy or gain in heat energy, but always there is some emission of heat energy from every body at every temperature. Now, based on this, there is a law that heat radiation emitted emitted at temperature capital T. So the emissive power is directly proportional to T power 4, directly proportional to sigma. So epsilon. So here comes the constant sigma, that is called sigma equal to 5.67 into 10 power minus 8 watt per meter square per Kelvin power 4. This is the Stephen's constant. So that based on which they can ask question, or W is nothing but P by A equal to sigma epsilon T power 4. So P equal to sigma epsilon A T power 4, or else Q equal to sigma epsilon A T power 4 into T. Anything they can ask, emissive power or radiation power or heat radiation. But if T naught is surroundings temperature, if they mention surroundings temperature, then you have to take the same formula as sigma epsilon T power 4 minus T naught power 4. Similarly, radiation power equal to sigma epsilon A T power 4 minus T naught power 4. But for perfectly black body, or sometimes they will simply mention black body, epsilon will become 1. When they talk about epsilon, you consider epsilon in the equation. If they are not asking you to find, if they did not give epsilon value, then you have to take epsilon value as 1. That means that body is perfectly black body. Now one more thing, when radiation is emitting, then the body cools down, and based on that Newton has given that rate of cooling d theta by dt, that is directly proportional to theta minus theta naught minus, where theta is average temperature of body and theta naught is temperature of surroundings. Now here, when body cools, suppose from theta 1 to theta 2 in time t1 and theta 3 to theta 4 in time t2, then what is the equation we will write is, for first case, theta 1 minus theta 2 by T1 by second case, theta 3 minus theta 4 by T2 equal to, now right side, theta means average temperature. That means theta 1 plus theta 2 by 2 minus theta naught by theta 3 plus theta 4 by 2 minus theta naught. So based on this equation, usually they will ask the question. Like we'll see, these are the two important things. Sometimes they can ask you, just I am telling you here itself, like Wien's law. So what is Wien's law is, from the surface when heat radiation is emitting, different energies will emit with different wavelength, and the wavelength corresponds to maximum intensity, maximum energy, that is inversely proportional to temperature of the body. So that lambda m into T equal to constant. This constant is called Wien's constant. That is 2.93 into 10 power minus 3 meter Kelvin. So based on that also sometimes they can ask question like lambda 1 T1 equal to lambda 2 T2. And here are our example questions. The first question is, see the two spheres of the same material and radii 4 meter and 1 meter are at temperature 1000 Kelvin and 2000 Kelvin respectively. The ratio of energies radiated by them per second. So the radiation formula is sigma epsilon A T power 4 into T. They did not mention surrounding temperature. Now here sigma is same for both of them, and epsilon they did not talk about. So epsilon is 1. Area is different. So Q is proportional to A T power 4 into T, implies Q is proportional to sphere. So radius, area means 4 pi r square. So r square T power 4 T. Here per second, so time is also you can remove it. Per second they are asking. So that Q1 by Q2 equal to R1 by R2 whole square into T1 by T2 whole power 4. Now radius they have given, temperature they have given. Radius is 4 by 1 whole square. Temperature is 1000 by 2000 whole power 4. That is 4 square means 16. 1 by 2 whole power 4 means 16. So 1 is to 1. Like that, direct formula based or comparison based question they can ask you. Now the next thing is, the luminosity of a star is 10,000 times that of sun. If the surface temperature of sun is 6000 Kelvin, the surface temperature of that star is. Now Q is directly proportional to T power 4. Now Q1 by Q2 equal to T1 by T2 whole power 4. Now one star. So this is for star. This is for sun. Now this is 10,000 times equal to the surface temperature of the sun they have given. So T2 they have given 6000 whole power 4. Now this I can write it as 10 power 4. So power same means base also should be same. T1 by 6000 equal to 10. Then T1 will become 60,000 Kelvin. Next question. If the wavelength correspond to maximum energy radiated from the moon is 14 micron. So lambda 1 is 14 micrometer. And Wien's constant they have given as 2.8 into 10 power minus 3 meter Kelvin. Then temperature of the moon is, see, lambda into T equal to B. Then temperature equal to B by lambda. So 2.8 into 10 power minus 3 by 14. Micro means 10 power minus 6. So T equal to 14 to the 0.2. So 0.2 into, if it goes up 10 power 3 it will become. So it will become 200 Kelvin. Now here is another question. A metal sphere cools from 72 degrees Celsius to 60 degrees Celsius in 10 minutes. If the surroundings temperature is 36 degrees Celsius, the time taken by it to cool from 60 degrees Celsius to 52 degrees Celsius is. So here first case theta 1 72 to theta 2 60 in time t1 equal to 10 minutes and theta naught is 36 degrees Celsius. Then they are asking theta 3 60 to theta 4 52 in time t2 how much? Then theta 1 minus theta 2 72 minus 60 by t1 by theta 3 minus theta 2 60 minus 52 by t2 equal to here theta 1 plus theta 2 by 2 72 plus 60 how much it will become 66 minus 36 theta 1 plus theta 2 by 2 minus theta naught by now 60 plus 52 by 2 so 56 minus 36 equal to this is 30 this is 20 so 3 by 2. Then if you solve this one then you will get the answer here 12 by t1 into t1 is 10 into t2 by this is 60 minus 52 that is 8 equal to 3 by 2. So 3 4 the 4 2 the 2 2 cancel. So t2 equal to 10 minutes. No, somewhere I did mistake. Twelve by 10 so I think options are wrong. So we are getting 10 minutes only. So just substitute properly like by taking theta 1, theta 2, theta naught and theta 3, theta 4, T1, T2. Next, similar question. A body cools in 7 minutes from 60 to 40. So theta 1 60, theta 2 40 and T1 is 7 minutes. So its temperature after the next 7 minutes. That means now theta 3 42 it will go to theta 4 something we don't know. Then in times again 7 minutes where the temperature of the surroundings theta naught is 10 they are telling. Now first case 60 minus 40 20. So 20 by T1 is 7 by here 40 minus theta 4 by 7 equal to. So now theta 1 plus theta 2 by 2 60 plus 40 by 2 50 minus 10 by 40 plus theta 4 by 2 minus 10. Now here 7 get cancelled. Next what equation will come? Here 20 by 40 minus theta 4 equal to 50 minus 10 40 by here if you take LCM the 2 will go up and here 2 10. So 20 plus theta 4. Now 0 cancel 2 cancel cross multiply it. So 20 plus theta 4 equal to 4 into 40. So 160 minus 4 theta 4. Now this you bring this side 5 theta 4 equal to this 20 you take that side 140. Then theta 4 equal to 28 degrees Celsius. So it will go to 28 degrees Celsius. That is the answer. So this way based on those things only they can ask the question. So this is how you can solve the questions based on Stephen's law, Wien's law and Newton's law of cooling. One of the important topic, every time they used to give one question based on any of these three laws. Similar questions I have given as an assignment. So just try to understand and try to solve it. So thank you all. We'll continue in the coming session with the next question.